Hey everyone, and welcome to the fourth day of trying to understand a little bit more with these trig functions. And the one we're going to look at today is going to be a little bit more with cosine. And we haven't really talked about cosine. We've been doing everything with the Ferris wheel problem in terms of sine. But one of the things I wanted to point out with this is that cosine is really not much different. The main difference between the two, or really the only difference between the two, is the sine function is determining how the height relates around. So, in a sense, like in the Ferris wheel problem, how high are we relative to the center of this function as we go around the circle? Well, there are also situations where horizontally, maybe going back and forth is what you want to look at, and that is what you call cosine. So, for example, if you start here at 0 degrees, cosine at 0 degrees is going to be the farthest you are ever going to get away from the center. Um, if you go up here to the top of this cosine function right up here, what you'll notice is that you're not left or right of the center, you're just above it. So that's why the sine is such a big number, or 1, and your cosine is going to be 0. And you can do that. I mean, there's a chart here, but you can also do that by just verifying it here. So sine of 0 degrees, well, how high are we? We're not really high at all. But if you look at cosine of 0, how far away from the center are we left to right? We are 1 unit away. So we are all the way out here. Um, Similarly, if you go to sine of 90 degrees, you're at your maximum height, but you are not horizontally going left or right at all. And what's kind of neat about them is they actually meet up in the middle at cosine and sine of 45 degrees. It's an irrational function, zero point 0.7. Uh, but if you've ever taken a physics course or know anything about the basics of just objects being moved, this right here is why 45 degrees is the maximum, the best angle to launch something out or throw something out if you're trying to maximize distance, because you're getting the most out of sine and cosine at the same time. So this is what cosine is. And what happens is when you just do a quick sketch of cosine, it starts at 1, goes to 0, goes down to -1, goes back to 0, comes back up to 1. The basic cosine function looks like this. One of the things you hopefully should recognize is that it'll keep on going. And if you look very carefully, this is cosine. If you shift it a little bit, this is the same sine function that we're doing before. So cosine and sine are really the same function, just shifted by about 90 degrees. And the same tools apply to cosine as before, as just in the sine functions do. So if you look at the cosine function up here and you say you want to add 1 to it, you just go here and you just move it up 1 unit and it looks like that. So sine functions, you can do the same exact thing with a sine function. And here you just have some questions, which is what happens to the height when you do this? Well, when you multiply it by 2, what happens here is the height of this function is going to double. What's going to happen here? Well, it's going to double in height, plus you're going to be moving it up 5. So these rules apply to both sine and cosine. How does the midline change? Well, if you think about it this way, if here is sine, and then you double it in size, the midline, the line across the middle, does not change at all. Again, the height would change, right? We're getting a lot taller, but we are not moving up or down from the midline. You really only move up or down from the midline when you're adding or subtracting or doing something like that. So what would these sketches look like? So here is your typical sine sketch, which is something we have seen in the Ferris wheel problems. Again, in the Ferris wheel problems, we're talking about hundreds, and this one we're just talking about 0, 1, and 2. So if you look up to this previous problem, if the sine function looks like this and we want to move it up 1, which is just adding 1 to it, it would then start here, work its way up, and back down. So this right here is the basic sine function, and this is the sketch of a sine function that is moved up 1. Same thing, if we double the sine function, we start here, and it's going to be, just much taller. So it's going to be because we doubled it, right? We doubled the height. So again, that number out front is our amplitude. It's telling us about our height of this function, both up and down. And the second number is going to be really moving the midline up and down from the original spot. And that's what you're looking for the basics of maneuvering these functions around. Good luck. Let me know if you have any questions.